Thanks everybody for attending this webinar series. We've got a number of items planned going forward as well with regard to signal interference. This particular webinar is a bit different. It's actually going to be a live demo of XCOM's Spectro-X Visualization Software, which we use for, and you will too, RF interference analysis. This is actually presented by I'll blow him up a little bit, but by one of the subject matter experts here at XCOM, Alex Boughton. As you can see in the agenda, we'll be addressing 1, what is Spectro-X? 2, what do you need? Why do I need it? And 3, what's in it for me, or the WIFMs, if you will. But before we get too far into this, I would like to turn this back over to Katie and run a brief poll, basically to gain an understanding of your familiarity with visualization tools. Katie?
You got it. All right, so on your screen, you should see just a very simple poll. What is your experience using this kind of tool, this software tool, to visualize our RF signals? You may have to exit out of the full screen mode to select one of the buttons, but go ahead and answer the question. And while we're waiting for everyone to vote, we've got about 40% so far. We'll just give it a few more seconds and then we will show the results. How's that? And I think Alex, or is it back to Julian? I'm not sure which one.
Back to me. I got it.
All right, cool. So yeah, why don't you just give it a few more seconds.
All right. So while we're collecting your response to the poll, what we'd like to do is go through and do a brief review on XCOM's visualization software and the WIFMs that come along with it. Essentially, Spectro-X is a very versatile software that provides visualization and analysis for up to 4 recorded RF signals simultaneously. To the point, Spectro-X is a valuable tool for system engineers, test engineers, especially when you're developing and analyzing a number of different platforms. For example, conventional and AESA radars, ELINT, SIGINT technologies, electronic countermeasures, ESM, multi-channel communications, and I can go through telemetry, MIMO, as well as other defense and commercial communications requirements. One of the main things that you'll see today is using this comprehensive set of tools within Spectro-X. 1, requires no programming. Number 2, can dramatically reduce the time needed to find and analyze RF anomalies. And 3, allows you to quantify signal behavior over time. Now, these recordings that you're going to analyze can range from microseconds to days in duration. Signals captured over the air using XCOM's IQC 5000B or IQC 91000A signal recorder and playback systems, as well as recordings made using other systems, playback files that contain signals or signal files that you may have created or captured within MATLAB or somebody else's third-party VSA. So today, Alex is going to be guiding you through a very high-level demo showing these items in detail. So before we turn it over to Alex, Katie, do we have the results from the poll?
There you are. Wow, we got a great audience. About half of you have never used this type of tool, so you're in for a real treat today. Hope you find it really useful, and it looks like we got a vast majority also either never used or novice. And we have a couple of experts out there, so they're going to keep you on your toes. Okay? All right, back to you, Julian.
All right, without further ado, folks, we're going to turn this over to Alex for the demo. Alex?
Thank you very much, Julian. And again, thank you everybody for joining us today. So we're going to go over a very brief demonstration here of Spectro-X, as mentioned by Julian. So what you're seeing here is the basic setup for Spectro-X with all of the default views open. What we'll see here go through these windows here for you. The top left window here is your playback summary plot. The playback summary plot gives you a magnitude versus time of the entire recorded file that you've inputted into Spectro-X. So this is kind of your overview of the entirety of the recording. One of the things you may notice on this screen is there's a few different traces. There are actually 3 traces on screen on the playback summary plot. Those are your maximum value, average value, and minimum values. And those are derived by taking a grouping of IQ samples within your recording and then calculating out those values and displaying those on screen as such. This is just to prevent, significantly large files that have very large number of IQ samples. It just helps speed up the ability to display the summary plot there. The plot directly below the summary plot is the playback scrolling time domain plot. This is again a 2-dimensional plot showing you signal magnitude versus relative time within your file. So as you're going through playing the file within Spectro-X, this gives you a bit of a sliding window into the bit of a smaller portion of your recording. The top right here, we have the playback persistence spectra plot. This is a 3D plot that gives you your magnitude versus frequency, as well as a heat map that reflects the persistence of the spectral components within your recording. As you'll see, once I begin playing with the file in Spectro-X, the spectral components will pop up and fade away if they are not very persistent within the overall duration of the file. The plot here in the bottom right-hand corner is your playback scrolling spectrogram plot. Similar to your waterfall display, for those of you that are familiar with a real-time spectrum analysis or analyzer, pardon me. This is again a 3-dimensional plot that gives you your relative file time, and this is the same window that you see in the playback scrolling time plot here. So your relative file time versus frequency, with then a heat map that correlates to the magnitude of those components. The final window here is the plot markers window. This will populate with any markers that you import from your recording or any markers that you populate inside of Spectro-X. And we'll go over that a little more within the demonstration itself. So I'm going to begin playing the file here in Spectro-X to give you a little bit more of an exciting viewpoint. But this is your file in Spectro-X. As you can see, the relative windows give you the kind of scrolling look here as your portion of the recording comes into view and you go beyond that. As well as up top here at the persistent spectra, you can see components populating and fading out as the file plays. So with Spectro-X, one of the 2 facets of viewing your recording is the ability to manually search through these files and find potential signals of interest. The primary way in which you control playing Spectro-X is found at the top of the window here with your playback control buttons. The first set of 2 buttons here are your play forward and play reverse. So as I'm playing the file right now, this is playing forward. It's going from the beginning of my file and playing through to the end, and I have it set to just loop continuously. So you'll see here as the persistent spectra disappears, I've reached the end and I've begun playing from the beginning again. The second option there is to play the file in reverse. So this goes from the end of your file and then plays the preceding events. This may be a useful function if, for instance, you had a very long duration recording file and you were interested in the events that happen at the end of the file. This would be a good way to quickly get to that point in the file. Or for instance, if you were playing your file in a forward fashion and you missed the event that you were interested in, you could simply essentially play it backwards and once again locate then the portion of the file you are interested in. The next grouping of buttons up top here are a stop button and a pause button. Now both of these buttons will stop your screen, and I'll get to we get to a little more something interesting on screen here. So either the stop or pause button both pause your screen. And what this will do for you now is you have both of the relative windows are frozen in time. So you can look at then just this one small window in your recording, as well as the persistent spectra reflects that as well. The difference being between the pause and the stop button there is if you've paused your file, you can begin playing from where you left off. Whereas if you were to stop or hit the stop button, when you go to play your file again, it will start back over from the beginning of the bounds that you've set. It's a bit of a difference there. Both, either way will give you a paused screen. It's just a matter of whether you're interested in continuing on from where you left off or starting the file over again. The next set of buttons here are a skip forward and skip backwards in time button. That is a configurable static jump. By default, it's set to jump forward and jump backwards 1% of the overall duration in your file. So we'll take a look here. I can jump, and what you'll see is as I'm hitting the jump button, I'm skipping portions of my recording, and that's reflected on the relative displays as well. So same thing as jumping forward. If I were to jump backwards, I can walk back toward events that I've already seen on screen. The next set of two buttons are which you see here is a 2x and a 1/2 x. These buttons control the playback speed of your recording. So what that will do is that will change then this relative time window that you see. So as I speed up my recording, we can get to the point where we can see the entirety of the recording on screen. And we can see here that our relative time axes has changed to reflect the amount of information that's displayed on screen. I can also slow down my playback. And that will also then show here the relative time window increases. And the information that's being displayed on screen is a bit slower. Makes it quite a bit easier to analyze signals if you're interested in getting an idea of start and stop and spacing between, things along those lines. Quite easier to catch if you slow down the recording.
Hey, Alex.
Yep, go ahead.
All right, I have a question that came in from Darius. He was wondering, can you add markers?
You absolutely can, and I will be getting to that shortly. That's another great point, that as you slow down or speed up your recordings, you may be looking to add markers to denote time, frequency, power information. I will get into that shortly here.
Thanks.
Those are your general controls for manipulating the playback of your recorded file. These help, again, as I mentioned, when you're manually searching through and going to visualize your recording. One of the benefits of Spectro-X is not only can you view one file, you actually have the ability to view up to 4 files simultaneously. I've just loaded in the exact copy of the same file here for the purposes of this demonstration. But as you can see here, each of your displays are now quartered, and the information is shown on each one there. One of the benefits of doing this, or one of the additional benefits, is that you have the ability to add in a time delay to your subsequent files. This may be useful, say, for instance, if you had two recordings that were not aligned within real time, or if you had, for instance, a recording from a transmit antenna and a recording from a receive antenna, and you wanted to better show then the differential in terms of receive time. And so here we go. I've just added in a bit of a delay, and what you'll see on screen now is, even though these are the same files, I've added in a small delay to each of these subsequent files. Again, as I mentioned, you may have files that are not co-located within real time, and you can adjust for that within Spectro-X. Okay. So back to the default view here, just for the purposes to continue on the demonstration. So beyond simply playing back these files and speeding up and slowing down to identify whether or not there are signals of interest within your recording, there are a couple of additional ways you can go about manipulating the display. The first of which is you have the ability to control the resolution bandwidth of your recording. Those of you that are familiar, that will change then the window size to discern between closely allocated frequency components. As you see here, the view now, we've got quite a bit larger noise floor because we've changed the resolution bandwidth, and these initial chirps in the beginning there seem to be more of a continuous signal instead of a bit of a splatter of information. You also have the ability to actually change and manipulate the bounds or axes of some of these windows as well. Begin with the playback summary plot window here. So as I mentioned, the summary plot by default takes a grouping of your I and Q samples and does a little bit of averaging on them and displays them instead of individually as groups. What we can do here is we can actually then zoom in on our playback summary and begin to get to where we can better see edges to pulses, as well as if we continue to zoom in even more, you'll see that my three lines begin to converge, and I can get to the point where I can now look at individual samples of my recording. To the individual that asked about markers, each of the windows in Spectro-X has the ability to add a marker. And so, for instance, as I zoom in on this pulse here, what I can do now is I can generate a marker inside of Spectro-X and indicate what I believe to be the rising edge there of my pulse. Now, to note here, the plot markers window, this does populate then the information of the marker that I've placed, gives me the actual real world time that correlates to that point in my recording, as well as the relative time within the file that correlates to that marker. Given that this is a summary plot and this does not have frequency information, there's not frequency correlated with that marker, but there is a power level. One of the things that we'll see here is actually that when I generate a marker in one window, it exists within the other windows as well. So we can see here on the relative time plot, there is the marker denoting the pulse that I selected out inside of my playback summary plot, as well as in the scrolling spectrogram there, we can see this is the time that correlates to the beginning of the pulse. And again, each of these windows allows for the addition of markers. So if I were to go to the scrolling spectrogram, for instance, I can also place a marker in this window, and it's correlated in each of the other windows as well. as well as the playback summary plot. If you come over to the scrolling spectrogram plot, for instance, and you wanted to zoom in on a single component within the spectrogram, you have the ability to change the bounds of this display. This will change here the frequency as well as time. And if I were to play my recording now, we'll have a nice zoomed in view of that single component that I selected. In a similar fashion, this allows me to more discreetly place markers if I saw fit, as well as get information in terms of the value of the peak of the peak there, as well as potentially bandwidth information, anything I see fit. Okay. So there are a couple of different ways of kind of zooming in, singling out, and identifying potentially anything of interest within your recording manually. One of the other very powerful tools of Spectro-X is that you can actually then take snippets from your recording file and export them into smaller files. The biggest benefit of this, and where we kind of tout Spectro-X in the analysis process, is if you were to take a very large recorded file, bring that then into, say, an analysis software or your own analysis algorithms, it may take a pretty substantial amount of time given the file size of your recording. Could be multiple gigabytes, potentially even terabytes worth of data. Spectro-X fits nicely into that equation, that it allows you to parse your recorded file, identify potential signals of interest within that file, pull out that IQ data, and send then the snippet of IQ data to your analysis software. The best and easiest way to go about doing that, or what I'll do here now, is say I'm interested in specifically this little portion of signal here. This is a Bluetooth hopper for any of those that are interested. Say I wanted to pull out just this specific bit of information, send that into my secondary analysis tool. I would go about zooming in a little more onto that signal there. And once I have a nice display of that on screen, what I'm going to do is I'll utilize my markers to denote approximately the beginning and approximately the end of that pulse there. Again, we can see that's reflected on each of these screens. Now down in my plot markers, we've got these listed as marker number 5 and marker number 6, and tied to, again, the time within the file for that information. What I can do here is by selecting the red marker number 5 that denotes the beginning of my signal of interest, I have the option here to set export start time, as well as then for the green marker number 6 there that denotes the end of my signal of interest, the option there to set that as the export stop time. Once I've done that, in Spectro-X, I have the option here to export IQ data. And within this window, we'll see that the time range that it is using is the same time range as reflected by my markers. So instead of having to manually try to figure out, type in approximations of the amount of signal I'm interested in and where it starts and stops, by utilizing my ability to zoom into signals and place markers in a more discrete fashion, I can better capture only the data I'm interested in. Again, with the added potential benefit there of speeding up any analysis that I'm doing down the pipeline. A couple of things to note here on the export IQ functionality of Spectro-X. This has the capability to convert the data file to a number of supported different data formats for analysis. Namely, the larger spectrum analysis players will work well with them, as well as multiple different software packages. So you do have the ability here, as I mentioned, to convert your data to make sure that wherever you're taking your data is going to play nice. There's a couple of different secondary analyses or processes that you can do during the export process. Namely, you have the ability to filter, decimate, and shift your data as you see fit. One thing that I will note, the export process does not in any way, shape, or form manipulate, modulate, or change the actual data in the recorded file. It simply creates a new file with a copy of the selected IQ data. So there's no concerns over losing any of your data by exporting it or to any secondary analyses. Okay. That is the general way in which you would go about using Spectro-X to manually parse through your recordings to be able to pull out then any signals that you have of interest or identify signals of interest for further analyses. There are within Spectro-X, as well as manually searching, Spectro-X includes the capability to, Spectro-X includes 3 automated search functions. The search functions function a little, or treat your information or your recording a little differently, but they each play a very nice role into helping you identify potential signals of interest so that you don't have to pay somebody to sit here and watch the very pretty display, albeit scroll by and hunt down for signals. So the first search functionality that I'm going to go over is called the carrier search. The carrier search is going to take your recorded file and it's going to search through for anything that it suspects is a carrier with modulation on the carrier. That's an important note. It does not typically play well with just tones. It's looking for suspected modulation. The parameters that you feed into the carrier search to kind of set it off is namely the power level that you're interested in. So the 2 options for that is an absolute power level. So you're looking for carriers that exceed the absolute value as designated. The secondary option there is above the floor. So above the floor, Spectro-X will calculate the perceived noise floor in your recording, and it will then take whatever additional dB you've specified above the noise floor and point out any suspected carriers that meet that criteria. Some of the additional settings are you can manually set your resolution bandwidth or allow Spectro-X to automatically choose the resolution bandwidth. Again, if you have some very close allocated signals that are meant to be identified separately as separate carriers, you may want to play with the resolution bandwidth and bring that down to better point out your closely allocated frequency components. As far as the time limits, you can specify whether you want to search through the entirety of your recording or if you wanted to search through a subset of time. So again, if you have a very large, very long file and you know that you've got multiple minutes of dead air that you're not interested in, you can very quickly say that you're not interested in searching through that portion and speed up the search algorithms. The secondary options here, first one here is tolerate dropouts. The tolerate dropouts option will allow you to specify a dropout time. So what this will do is that if you have a single frequency or Spectro-X comes up with a single suspected carrier that exceeds the power level threshold that you've set, but then it were, say, to fall below the threshold for a short duration and come back above the threshold, by default, Spectro-X is going to treat those as 2 separate suspected carriers. By adding in the option to tolerate dropouts and specifying the maximum dropout time, you can have Spectro-X better identify single carriers that have some amount of fluctuation to the power. The frequency smoothing option simply aids Spectro-X in identifying spectral component groupings so that carriers are better identified as individual carriers versus a splattering of spectral information that does not have any amount of correlation. So I'm going to run a quick carrier search for you on our recorded file here. I'm going to set an absolute power threshold of -50 dBm. So if we were to take a look on our summary plot, for instance, I'm searching for anything that falls, or excuse me, rises above the -50 dBm threshold. That is a suspected carrier. I'll allow Spectro-X to do the resolution bandwidth. I'm going to search through the entirety of my recorded file and going to leave everything else as default. Now, when I hit apply on the carrier search here, the search function does not start on its own. The reason behind that is, again, if you have a very large file or very broad search criteria, your search function may take a decent amount of time to complete. So we don't automatically jump off into the weeds with that until you're ready to begin the search function. But once I've set my parameters up at the top here, we have these two little binocular buttons, and one of which is the search start, and the one with the little red X will stop the search in the midst of running. So as I've got my parameters already set up and good to go, I'm going to go ahead and start my search function. As I start my search function, you'll see the results window pop up and begin to populate. And once this is finished, I know it was a little quick, a little hard to see there, but there was a progress bar down at the bottom of the window that reflects the progress of your search. I'm going to run that once more just to better highlight that progress bar. So if you look at the bottom of the screen to where it says playback progress down here, you'll see a search progress bar pop up as well. And so there we have, again, as your search finishes, you'll get your results displayed with some general information. Again, as these are suspected carriers, we treat them as such, and we report some general information to you. Namely, we have the frequency that we believe the carrier is centered upon, the bandwidth of said carrier. The start time is actually the start time within the file itself, so that's relative to the file. The duration of the carrier, how long it persists above the power threshold we've specified, as well as the calculated power of the carrier itself. Now, a few things to note here. In your results window, you can click on a result and then view the suspected carrier in the spectrogram view. It also has a marker at the calculated beginning and end of your suspected carrier here. Beyond simply just the spectrogram display, you also have the ability to view the suspected carrier or your suspected result, depending on the search you've run, within the time domain as well. So we can see here that this pulse here is what's being shown on the spectrogram. This is the suspected carrier that's being reported by our search function. There are a few other views you can see as well. One that is typically of interest is the IQ versus time. This gives you a better look at then the actual IQ data of the recorded event, if that is potentially of interest. Now, within the search results window, it will also tell you here the number of overall results found in your recording. So if you take a look here in my recording, or in the file that I'm using for the demonstration, which is about 37 milliseconds in length, there's a suspected 9,000 carriers within this recording. And now again, I personally would not want to manually click through and look at each one of these. And so we have what we call the pruning functionality within Spectro-X as well. The pruning functionality allows you to take the search you've just run and add secondary criteria to the search that you've run. Multiple criteria you can select. You can select multiple criteria at the same time as well. But if you take a look here, you've got options including frequency, frequency range, bandwidth, start time, duration, power, things along those lines. It's important to note here, this is a pruning functionality, and so we are asking to remove results given these secondary criteria that we're inputting. Now the idea here is if you know a little bit of extra information of what you are looking for, or at least what you are not looking for, this may play into that. So what I'm going to do is I'm going to set up a secondary parameter of interest to me. And what I'm asking Spectro-X to do here is to rerun the carrier search with the -50 dBm threshold. So I'm going to get my 9,000 some odd results. And then I want to pare that down or prune that down to only results that are within the 80 to 90 microsecond. So again, important to note, I'm removing results if they are outside of my 80 to 90 microsecond range. I hit apply, I run my search once more, and you'll see my 9,000 results comes down to 8 results. Significantly more tolerable. Again, you can click on each of these results, view them in the spectrogram as well as time domain, IQ, whichever display is important to you. The pruning functionality is very powerful, as I mentioned. The difference of 9,000 results to 8 results in a 37 millisecond file is quite extreme. And again, if you had multiple minutes worth of recording potentially, or even days worth of a recording, your search functionality could certainly spit out a very large number of results that you don't necessarily want to sit and bog through. So if you know some additional information of what you are or are not interested in, the pruning can help with that. One thing I will note in the search result window for both the normal carrier view as well as the pruning view, beyond that you can switch between the two of those, which can be quite nice. There's also the ability down here to save your results to a file. Highly recommend using the save functionality when possible, where possible. If you run a search that takes a very long time to process and spit out results, probably worth then saving off the results to speed up any future references to those. The pruning capability can be done on a saved search file. So if you take a search that takes a long time to run and then want to come back to it at a later date and prune the results, very possible within Spectro-X, as well as you can take your search results that you've saved off and import those into a spreadsheet like Microsoft Excel or something, for instance. And those will be pulled in as a comma separated values that you could then apply querying to as well. So within your Excel spreadsheet, you would get the same information that's presented within your search results. The second search function that I'm going to go over is called the pulse search. The pulse search has very similar parameters initially. Namely, you have a power level you're going to set for your pulse search, time increments, as well as a few additional options. Pulse search differs from your carrier search in that Spectro-X is not interested in whether or not there appears to be any amount of modulation or anything along those lines on the pulse. It's simply going to say if the signal rises above the power threshold and falls below the power threshold, it's considered a pulse, regardless of what happens between those 2 points in time. I'm going to run the same criteria that I just used in the carrier search to demonstrate the difference there between. A couple of points here in the options column. You have the ability to compute the pulse frequencies. So if the pulse appears to have a preceding or prevalent frequency, that information will be calculated and displayed, as well as a smoothing ability. So if you have a pulse that dances right around the threshold that you've set, similar to the dropouts within the carrier search, you can dictate to identify those as individual pulses or not. So again, as I've set my parameters, go up and start the search function itself, and we're going to see our results. So given the same power threshold and time limits that I set on my carrier search, I've gone from 9,000 suspected carriers to 12,000 suspected pulses. Now, again, given that this is being treated as a pulse, there is some information that we've calculated within Spectro-X as well to give you some information based on the pulse characteristics. You can see, for instance, we have your pulse width, rise time, fall time, average power across the pulse, peak power across the pulse, Then again, start time is start time relative to the file itself, as well as then, as I mentioned, calculated frequency, additional information. One of the nice things within the pulse results is you have the ability to sort these results based on your parameters. So if you're interested in the pulse widths, you can sort based on pulse widths, going from largest to smallest or vice versa. Same with the carrier search. You have the ability to view these pulses on both the spectrogram and time displays. So very similar to carrier search, just simply the criteria for what dictates a result is different. And as with the carrier search, there's also the ability then to prune the pulse search results, again, given additional criteria that you're interested in. In the interest of time, I'm going to move on to the final search function within Spectro-X. This is the waveform search. The waveform search is quite different from the previous two searches in that the criteria you use for a waveform search is going to be a reference file. Now, this reference file I'm pulling in is a file that I have previously clipped out of this exact recording. But what we're going to do is we're going to take my reference file and essentially ask, does this file or something similar to this, this RF pattern appear or happen within the recorded file I'm looking at? So this would be, for instance, if you had a certain fingerprint to a certain system you were interested in, you could say, does that system appear within this recording? Or does this transmission appear within my recording? You can select a single file as your reference. You also have the ability down here to use all files within the directory. So if you, again, have built up a fair number of signatures or fingerprints, you can search across all of those and say, are any of them present in this recording? You also have the ability down here, again, your time limits, as with the other functions. There is the ability here to change your frequency searching. So by default, it's going to take your reference file and lay it over the center. So the center frequency of the reference and the center frequency of your input, your recording are co-allocated, and it's going to just simply slide in time the reference file. You have the ability to instead set frequency parameters that you're interested in, including a start and stop frequency to slide, as well as the increment of your frequency bounds. There's ability again as well to apply passband filtering. So if you have a file that has a lot of noise that you're not interested in, or you're only interested in certain sections of the frequency, you can set your passband as well. And the confidence limit at the top here is how close of a match do you need to report a result. I generally recommend a very low confidence limit to begin with. I'm going to run a quick demo here for you. And what we're going to do here is I'm going to search through the back half of my recording, as there's a few linear frequency modulated chirps included in this recording. You can see them here in the summary window. I'm going to simply search for whether or not these are comparable to the file, my reference file. They certainly are. In fact, the reference file is just one of those chirps. But let's go ahead and take a look at the results. And so here we have again our waveform search. We have our carrier frequency, start time, confidence percentage, and the reference file to which they are correlated to. We can again click on and view these recordings and potentially identify anything of interest. For instance, here we have a linear frequency chirp that did not create quite correctly as we would expect. And we could use that information to say, is this indicative of a certain type of system or what? So again, with the waveform search, setting a low confidence limit can sometimes introduce some very interesting results that may be worth further analysis. One difference to note with waveform search, there is not a pruning functionality. The waveform search itself, the confidence limit, as well as frequency limits that you set, that's going to be what dictates the number of results you may or may not receive. So that's the end of the very brief and broad overview of Spectro-X, how to use it to manually search through your recording files, as well as utilize some of the search functionality. And I believe at this point, we're going to throw it to Katie very quickly for a brief poll. Katie, if you would, please.
Yeah, thank you, Alex. Okay, so I know we got a couple questions that have come in. We'll get to those in a second. But in the meantime, let's just, out of the three the search functions that you just saw Alex demonstrate, which one of these three do you think would be most important to you? All right, so go ahead and vote. But in the meantime, while everyone's voting, let me ask a couple questions. So I'm going to read this exactly how Matthew worded it. So this will be to you, Alex. So he goes, this software could be used to determine what kind of interferer exists within an airspace based on the type of signal. Would it be possible to determine if 5 gigahertz Wi-Fi is interfering with a 5.8 gigahertz point to multipoint network? I'm assuming the form of transmission could be used to determine the interfering type of signal. So do you want to take a stab at that? And I kind of answered
Yeah.
him, but let's see if I answered correctly.
Yeah. So,
This will be my test.
yeah. So, yes, it certainly could. Spectro-X has the ability to read in, then, as I mentioned, single files all the way up to 4 files simultaneously. So, if you have a system where you're recording both of those frequency components you're interested in, or a single recording that contains all of the spectral components, you could use Spectro-X to see whether or not you have a degradation in the communications platform that you're interested in, or potentially if it's interfering with the, I believe you said the 5 gig Wi-Fi is interfering potentially with any of the sidebands or channels for your communications network. So yes, that would be certainly a good fit for Spectro-X.
Yeah, well, I passed because that's why I exactly answered that question. Well, I said yes. So fantastic. Another question is, so what are the capture options? This is coming from Rob. I'm
The
assuming.
capture
Go
option.
ahead.
So yeah, I believe potentially we're asking how can we go about capturing the data
Capturing.
to view in Spectro-X then?
I'm thinking so.
So primarily, we tend to use our IQC product line. Our IQC products are our XCOM digital IQ recording devices, high-speed recording devices. And so we would generally take the IQ data captured from our digital recorder and bring it into Spectro-X. Also, if you're familiar with a real-time spectrum analyzer, multiple real-time spectrum analyzers have the capability to do very short duration IQ captures. Generally, I think, for instance, I know Keysight has a size limitation of, I believe, 2 gigahertz of recorded data instantaneously. So you could take the data out of your real-time spectrum analyzer that you've captured in a digital IQ format and bring those into Spectro-X for visualization.
Exactly. And I know we are just enabled the features through an Enritsu real-time spectrum analyzer as well.
Correct.
So
Which is
yeah,
also
so there's
handheld.
exactly, it's a handheld device. So here, let me share the results of the poll, and you can see, well, 73% said the carrier search. Looks like that would be most important to the audience, then followed by waveform search, and then last pulse search. Very interesting. Okay, Alex.
Thank you. Do we have any more questions we'd like to take, Katie, or should we go into the summary?
So another question from Rob was, so any real-time spectrum analyzer can create recordings, is the question.
So that would be up to then the real-time spectrum analyzer. I can say for certain that our XCOM digital recorders that we use interface with Tektronix real-time spectrum analyzers, Keysight real-time spectrum analyzers, Rohde & Schwarz, as well as an Anritsu real-time spectrum analyzer. So I know for certain that our digital recorder interfaces with those. As far as the spectrum analyzer itself, I know for certain that Keysight has that capability to capture IQ data as a standalone, and I believe Tektronix does as well. But that would be kind of something you'd have to inquire about specifically with each of the spectrum analyzer manufacturers and which model you're interested in.
Okay, thank you. Let me just see if I have any other questions that's coming up. What else can I do with exported signal data?
Perfect. So there's a multitude of things you can do with your exported data. The one that I spoke to was, of course, sending that off to secondary analysis software. So for instance, if you were looking to decode the phase shift keying of a piece of signal, you could certainly take the exported data, send it on to that. If you had a MATLAB functionality or a scripted algorithm that you were doing some amount of transforms or analysis or comparison, you could use your exported data within that. And actually, one of the powerful things that we do with our exported data is we create new waveforms using snippets from the waveforms that we've captured. So for instance, the file that you've seen me using in the demonstration today was a snippet from multiple different recordings that we stitched together using another piece of software we have called RF Editor. And then we tied all of that together into one continuous recorded file. So for instance, in the file, you may have noticed there was some Wi-Fi, there was the Bluetooth hopper I pointed out, some linear frequency modulated sweeps or some chirps, as well as some interferers that we injected. So you can take your exported data and actually create new waveforms for analysis or even regeneration and playback over RF.
All right, fantastic, Alex. Okay, I think we're about out of time on this one. So thank you so much for the demo. I learned something every time you do it. So what we're going to do is I want to thank everyone for joining us. And if you have any questions, by all means, connect with us at XCOM.